In the last video, we were talking about catching errors so that our program doesn't crash in the middle of running, a runtime error. And we did this with this try-catch block. So the first part of this block says, go ahead and give this, in our case, give this operation a try, give this expression a try. If it doesn't fail, the right line will print, and the catch block gets ignored, and the program continues on. If this generates an error, the right line will never run. It'll skip directly to the catch block. The catch is accepting all errors into this exception object, and then the right line occurs. Now, I'm going to run this. Let's put it on. I'm going to do a breakpoint here so I can catch it and look at it line by line. When I run it, we're getting a divide by 0, so I'm going to continue. And what I want to share with you is down here at the bottom of our locals window, we can, if I hold my mouse over this particular error, I can see that this error is called a divide by 0 exception. So this is a very specific error. Exception is a generic error. It catches all the errors. But if I want to get a little bit more specific, this particular error is a divide by 0 exception. And so this is more specific, and so I can therefore catch it with another catch block. In other words, I can do exactly that divide by 0. So I can catch the divide by 0 and write a more specific error message to the user. So let's run that and see what happens. Okay, actually I'm going to take my breakpoint off and we're just going to run it. And if I bring my console window over, you can see that in fact the you cannot divide by 0 error caught. So this line was run, and then the program was able to exit gracefully. Let's look and see what happens if I reverse my catches. So I'm going to put this generic catch above my specific catch. And you see right off the bat that I start to get some red squiggly lines, the dreaded red squiggly lines. And what this error message is trying to tell me, just leave it up because I can't point to it, but see at the bottom line says a previous catch clause already catches all exceptions. What this error is saying is you need to make sure that you put your more specific exceptions or errors before the more general. In other words, I need to be specific, so catch this one, and then make sure your most generic one is towards the end. So in order of specificity, that's a tough word for me to say. So whichever is more specific comes first, and then our more generic ones come last. And so now I should be able to run this, and everything is going to run smooth. We've already seen that happen. Okay, so I'm going to add to this divide by 0 exception. I'm going to put in just a general variable name. I'm going to call it E because that's kind of pretty standard. It's what people seem to use. So E can really be anything, but I'm going to use this variable name E. So as you can recognize here, I'm catching an object. So this is actually an object, a divide by 0 object. And E is a variable that's going to hold on to that object, which means that, or it's going to give me reference to that object, which means that I can do something like this. I can do a right line, and I'm going to take that object, variable name, E, and I have properties that I can now write or have access to because it's an object, it's a class with properties. And so I'm going to use the message. And if we run this, what you're going to see is, let's just run it and we're going to see two different messages returned. One is our generic message, the message that we provided for the right line. And then this is the system generated. We saw that when we looked at our runtime error. So this is provided by the system, by the compiler, and this one's provided by us. So you can choose which one you feel is most appropriate to view. But what we're demonstrating here then is our ability not only to catch the error, we're catching it as an object. And so we have a variable that we're assigning to that object. So we now have an object of an error. I know this all sounds very funny. And then we're going to have properties that we can utilize. And in this case, we're using the message property, which will enable us to see the actual error message that's generated by the compiler versus our error message. The last thing we're going to do is add on what's called a finally block. And I'll write right line finished, for lack of anything more clever. And the idea behind the finally block is no matter which of these two run, if try is the portion of this block that executes, finally will follow. If there was an error that happened, maybe a divide by 0, and this portion of the catch block is what ran, that's great, print your message, and then print finally. If this portion of the catch block ran, that's great, execute the right line here, print out this message, and then run this block. And the reason for this is if there is something like perhaps we opened up a file and we're reading from that file and an error happened, we want to not only generate an appropriate message, in this case obviously it's not going to be a divide by 0, but we don't want the system to just end. We want to make sure that that resource is closed, for example. So finally is going to run no matter what happens, whether our try works, whether any of our catches work, no matter which block is run, then our finally is going to execute. And again, that's to make sure that we have access to our to any of our resources or whatever we need to do to execute, to finish whatever resources we might have open or anything else we might need to make sure we complete before our program runs. And so finally is just that. After all of this, finally run whatever's in this code. For example, close that particular file out. So I suppose we could just run this just to watch it work, verify that in fact what you said is the truth. So let's run through our code. I've got my breakpoint. I'm going to run, step through it. I did in fact get a divide by error, 0 error. Lines are going to be written, and then we should see the finally is what ends up executing. So in that case, the finally ran despite the fact that we had an error message for an error. And if we look at our console, we can see that we got all 3 of those error messages. These were in the catch block. This was our generated error message. This was the system generated error message. And then this was the finally's error message. And then if we actually did something that's not going to generate an error, we can watch that run as well. And so here again, we can see, oops, I shouldn't have done that. We can see that if I run this, continue to step through it. In fact, that did execute properly. There was no error that was thrown. So we should print our result. And the catch blocks, both the catch blocks are skipped. And we get to the finally block and the finish line runs. We ran to the finish line. Oh, sorry about that. Okay. And so if we see our console window, we can see the result. And then we see, of course, finished. So that's the try, catch, finally block. Recognize that the finally is not necessary. Everything can run without it. We can have more than one catch block, just making sure that our more specific errors are caught before our more generic errors. Remember that we can catch that object. So in this case, our divide by 0 object, or we could have also done the same thing with exception. We could have caught that as well. So now that we have that object reference held in a variable, we can access the properties of that variable or that object. In this case, what is the message that's generated by the compiler? And then, of course, our try portion, which is if everything executes correctly without any errors, go ahead and run this code. So this is exception handling, making sure that we catch a runtime error so that we can handle it, so that our program, one, can exit gracefully, so we give the appropriate error messages and we get control of the program instead of it just crashing. And then our finally portion, which allows us to do anything that we might need to close or to handle or to wrap up before our program exits in case of runtime errors.